Hi and welcome back. I've been talking with Dr. Paul Herrick, the author of the textbook that we've been using in this course, Think with Socrates. In the last video, we talked a little bit about logical structure, deductive reasoning, validity, and the relationship between content and structure. And we're giving you this content now prior to you getting into the lesson so you can be prepared for the stuff that you're going to be learning in the next couple of modules. So what you might do is, as we walk through the next set of slides, as you're working through the lessons, if you get stuck, come back and review this, because I think once you start getting into the material, a lot of what we're going to talk about here is going to make a lot of sense. But what we want to do now is walk you through some examples of deductive reasoning where students tend to look at arguments that we're going to show you and they evaluate them in the wrong way. And Dr. Herrick is going to talk a little bit about why that happens and how you can actually work through looking at these arguments and kind of land on the right answers. So some of the stuff that you're going to see in here you will see on assessments. So it's going to be worth your while to take some time and make sure you understand this so that when you get to the assessments, you can do a better job of evaluating how you need to answer those questions. So why don't we jump in? We've got a couple of slides here. These slides were put together by Dr. Herrick earlier, and he's going to talk you through some of these examples. So what's going on here?
Okay, so the slides that we're about to look at, I chose because I think they show how the study of logic can improve your reasoning.
Yes.
So when students first look at an argument like this, before they've studied logic, their first guess is that the reasoning looks correct. And it does on the surface appear to be correct. If no birds are fish and no cats are birds, well, it's true that no cats are fish, and it just looks correct to students at first. It actually is an invalid argument, but it's not obvious, so we have to apply some principles of logic. Aristotle actually developed a system of logic that was very mathematical in nature, and by using that system of logic, he could actually show that this was invalid. But this is not a valid argument, meaning the premises by themselves, the information content of the premises, all by itself, does not conclusively establish the conclusion.
But these facts seem correct. No birds. It's true that no birds are fish. It's true that no cats are birds. So why is this invalid? It doesn't.
Okay.
It might not make sense.
Yeah. So this is an example of an argument that has true premises and a true conclusion, and yet it's not correct reasoning. It's not valid. So let's think about it. When we say that no birds are fish, we're telling you that there are no birds in the fish category.
Right.
But we're not telling you that there's no, we're not telling you that there are no cats in the fish category. We're not saying anything about cats in this very first premise.
Correct.
Okay, now the second premise says there are no cats in the bird category, but that doesn't tell us anything about the fish category, if you think about it.
So the terms aren't relating to each other properly in the premises. Is that what you're saying?
Correct. They're not relating to... Just because there's no birds that are fish and there's no cats that are birds, it does not follow. It's not conclusively proven that no cats are fish. So this is an example of an invalid argument.
So the point is that even though these are stating true facts, they're not related to each other in the right way to draw this conclusion. It doesn't make these facts false. It doesn't make the statements false. It just means that you can't get to this statement by believing these two are true. And again, we're going to work through this process in the rest of the lessons in these modules, and I'll try to show you why that's the case, and we'll use material from your book to kind of illustrate this. But what we're trying to show you is that when you first read this, if you saw this on a test, you might say, yeah, that's a valid argument. Well, it's structurally invalid even though the facts that are being stated are true.
Now, I'll give an example to show. Paul, you said something very important. It's structurally invalid. Validity and invalidity are due to the form of an argument, the structure, not to the content, not to what the arguments are about, which we talked about in the previous video.
Yeah.
So let me give you a parallel argument. This argument is going to have the same structure, the same form, and you're going to see that it's clearly not good reasoning. So should I erase this?
Yeah, you can go ahead and erase that, yeah.
Okay, so when I started teaching, we used chalk
Yes.
and blackboards. So let's look at this parallel argument. No Microsoft employees, I'm going to make some room here, collect stamps. No stamp collectors are artists. So, necessarily, no Microsoft employees. Do Microsoft employees mind being called MS employees?
It's totally fine, yeah, that's appropriate.
Okay. No Microsoft employees are artists. Now, if you examine this, this argument has the same logical structure as this argument.
Correct.
Except we've substituted Microsoft we've substituted Microsoft employees for cats. And we substituted stamp collectors for birds and so forth. Otherwise, the abstract structure is the same. In other words, the logical form is the same. Now, obviously, the premises do not establish the conclusion with certainty.
Right.
It's possible the conclusion is true, but the premises don't prove it.
Right.
No stamp collectors are artists. Suppose that's true. And suppose no Microsoft employees are stamp collectors.
Yeah.
That would not prove that no Microsoft employees are artists.
Right. Even though all three statements could be true.
Could be true that they're
you
true.
can't get to the conclusion from the two statements.
Yes, and in terms of information theory, the information content of the premises by itself doesn't include the information content of the conclusion.
Correct.
So this is both of these arguments are invalid because they instantiate, as you'll learn, an invalid form. Anyway, the point I was making is before students have studied logic, they'll look at an argument like this and it looks valid to them until they learn some logic and think about it more critically and they realize it's not correct reasoning.
Right. Cannot get to the conclusion from the premises.
Exactly.
And again, we'll look at all these terms, we'll look at these concepts and how you can arrive at the right conclusion using the proper reasoning as we move throughout the course. Let's look at another example.
Okay.
If I can make that happen. Let's see, there we go.
Okay.
So this is a similar situation, but
similar.
Yeah.
Yeah. So again, the form of the argument is the problem. It's not the content, it's the form. The form is sum A are B, where A and B are categories of things or names of categories of things. Well, here's what I'm going to do. I'm going to rearrange these letters. Some A or B, and then some B are C. And the form concludes so. So and therefore mean the same thing. So some A are C. Now, students, before they've studied logic, will look at this and it looks okay. And explain, Paul, why it's not okay.
Again, for the same reason that we saw in the last argument, while these statements can be true, right?
And probably are
true, you cannot use the truth of these statements to arrive at the truth of this statement. So if you just look at the truth of the statements, you might say, yeah, that seems like a good argument. That's a valid argument. It's a valid form, right? You might not say that until you studied logic, but you would look at this and say, I would think this is okay. I would give it a check mark. Looks okay.
On the surface.
Correct. But if what you're, in an argument, what you're trying to do is arrive at the truth of this statement by believing the truth of these two statements. And you can't do that with this form.
Yeah, in other words, even if these are true, even if that's true and that's true, that by itself does not prove
Correct.
that this must be true,
And
which
that's
is,
what
which
an
is what
argument-
necessarily means.
That's exactly right.
That doesn't prove this must be true.
Now, we would encourage you to pause the video and look at this argument and see if you can see intuitively, before you've learned the principles, why you cannot arrive at the necessary truth of this statement by believing those are true. Just look at it and you'll be able to see that the conclusion does not follow from 1 and 2, which are the premises. Right? Just intuitively.
May I suggest a counterexample?
Sure.
Okay. So logicians call an argument a counterexample to an argument if it shows that the target argument is improper or illogical. Here's a counterexample. Suppose I say some programmers. Is it okay if I pick on programmers?
Yeah. We're used to getting picked on.
Some programmers are magicians.
I think most of the programmers in the audience would say all programmers are magicians.
Well,
but
actually, it's
we'll set
magic
the-
what they do, because most people would
Yeah, I don't know.
find it magical.
Yeah, that's true.
Okay, some programmers are magicians. Some magicians collect stamps. You know, did you know that stamp collecting is a worldwide hobby?
I did not know
It
that.
is worldwide.
Wow.
Yeah. Okay. Some programmers are magicians. Some magicians collect stamps. And then the conclusion would be what? Some programmers collect stamps.
Yeah.
Yeah. Now, I don't know if there are programmers who collect stamps, but these two premises would not prove it.
Correct.
Even if it's true that some magicians collect stamps and some programmers are magicians, the problem is that this premise doesn't tell us that the programmers who are magicians are among the magicians who collect stamps.
Right.
Because some magicians collect stamps, it doesn't tell us they all do. So I don't know if the programmers who are magicians belong to the group of magicians who, who are programmers or who are outside that group.
Right.
So this reasoning does not connect.
Yes. And you'll see a valid form of reasoning, a reasoning where that does work in just a moment in some of the other examples. But clearly in these examples, you cannot get to that final statement as a necessary conclusion based on the premises.
And so in logic...
And you'll learn the principles of this as we move through the lessons.
Yeah, it's a principled distinction. But in logic, we call this a fallacy,
Yes.
meaning a mistake in reasoning.
Correct.
And again, this, I think, if you study logic, you spot mistakes in reasoning
Yes.
more easily, more readily. So you're more tuned into the structure of an argument rather than its content.
Good. Which is the point of studying logic.
Yeah, I think if you look just at the content, it can mislead you, because looking just at the content, you can say, oh, that sounds fine. But when you think about the abstract structure, you say, wait a minute, there's a problem here.
Yes, correct.
This doesn't prove this.
Right. Exactly. Here's another example.
So, all vegetarians are artists, all programmers are vegetarians, so all programmers are artists.
Valid or invalid?
So, is it valid or invalid?
So the question is, can you conclude this as an absolute necessity if you believe that these two statements are true?
So if you think about it, this is a valid argument. You have to think it through. But if you'll learn the Venn diagram technique that can let you visually see that this is valid. If all programmers are vegetarians, every one of them, and every vegetarian is an artist, then it necessarily follows with complete certainty that every programmer is an artist. This is an example of a valid argument.
That's correct.
Now, it's interesting, the premises are probably not true, and it's still valid. So this bothers students, and
Now let's talk through that for just a moment.
Okay.
What is going on here? If you have false premises and you have a valid argument, how do the two relate?
Well, this issue. How can an argument be valid and have false premises? Bothers all logic students, and it takes a while to get over it. It's a hump. Valid, I have to stress this in logic class, valid does not mean true. In everyday life, we often use the word valid to mean true.
Yes.
You know, and you say something, I say you're making a valid point, and I just mean your statement's true. In logic, valid doesn't mean true. What valid means is if the premises are true, there's the premises. If the premises are true, the conclusion must be true. If it were true that all programmers are vegetarians, and if it were true that all vegetarians are artists, given those two hypothetical facts, this would be true.
Right.
That's what valid means.
Yep.
But the premises don't have to be true for an argument to be valid. This is, in fact, one of the beauties of deductive reasoning is that we can reason from one premise to another, from one idea to another, without worrying about whether our starting point is true or not. And then logic can tell us whether our reasoning is correct.
Yes.
Whether our premises are true is a separate task.
And we'll separate those in the course. We'll talk through the structure part of making an argument and the content part of making an argument as two separate things, what we call truth value
Right.
and validity.
Right.
And we've been using terms premises and conclusions. You'll learn about those. Premises are just the reasons that you offer for something else to be true. If you believe the reasons, you should conclude that the final statement is true.
And I might add a philosophical point, Paul.
Sure.
The ultimate goal of reasoning is to get at the truth of a matter,
Yeah, that's very
or the
good.
truth of some matter. That's ultimately why we reason. And so if an argument is valid, and in addition it has all true premises, well, I should say if a deductive argument
Yes.
is valid, and it has all true premises, we call that argument sound. So soundness for deductive arguments is what we're ultimately after.
That's correct.
We're after arguments that have true premises and their reasoning, their internal reasoning is valid. And so sound brings in truth.
Right. So what you're going to learn in the course is to separate those at the beginning so that you can construct better arguments, and then you bring them back at the end to produce sound arguments, which is really your goal.
And this can help you in everyday life.
For sure.
Because sometimes we reason with each other and someone's reasoning with us, and we know they're starting with some false premises, but we also know their reasoning isn't correct. And so what we can do is we can, like you said, we can divide our job into two parts. Part one is we talk about their reasoning.
Yes, correct.
And we try to show them that their reasoning goes wrong. Part two is when we ask, okay, but now your premises, there's a problem here. One of your premises isn't true. Right. And so we can look at the truth of the premises in one operation, we can look at the validity of the reasoning in another, and then when those two go together, you have a complete analysis.
Great. All right, let's look at another argument.
Okay, so this is another deductive argument. What makes it an argument is the word therefore. What makes it deductive is the word necessarily. So this is an argument because we have premises offered for a conclusion. This is deductive because the word necessarily indicates that the claim is that if the premises are true, the conclusion must be true.
That's right.
So it's a deductive argument. And this argument is not valid. But most students, before they've studied logic, look at it and it looks correct. They look at it, it seems correct. But if you analyze it and think about it, it's actually not good reasoning. It's not valid reasoning. So do you want to explain why, or should I?
Well, since you're our guest, I think you should
I have
explain
to
it, because
do the work
they're going to
here.
hear plenty from me in the course and the rest of the course.
Okay, I have to do the work
Yeah,
here.
that's
So
right.
suppose if Malia goes swimming, then Jose goes swimming. And I'll interpret that to mean every time Malia swims, Jose swims. Does that premise alone now, just that premise alone, tell us that every time Jose swims, Malia swims.
No.
It does not, does it?
It does not.
It tells us every time she swims, he swims.
Correct.
But does that premise leave open the possibility that he swims alone sometimes?
Yes.
Say it does. So just because when she swims, he swims, it does not logically follow that when she does not swim, he does not swim. He might swim every day, and she might swim every other day, in which case, if she swims, he's swimming with her. If she swims every day at 9 a.m., and he does. But on the days when she doesn't swim, he might swim anyway.
Yes.
Now, the second premise simply adds that Malia will not swim today. So given just the two premises, the conclusion isn't proven.
Right.
We are not guaranteed that Jose will not swim. Maybe he will anyway,
Yes.
without her. So this looks valid, it looks correct on the surface. It's an example of a fallacy that can mislead people if they haven't studied logic.
Right. Now, I want the students to take a look at this. You might pause the video and study this. And how would you change the premises and the conclusion so that it does seem as if the conclusion would necessarily follow
That's
the
a
premising?
that's a good exercise.
So you may not have the skills just yet if you haven't gone through the course material yet to do that, but this is something that you may want to revisit later. Try this as an exercise. Look at this invalid form and see if you can change it into a valid form, and you'll see a valid form in just a moment. Oops.
And the change is very small.
Correct. It's a very minor change, but see if you can do it, and then once you can get to that point, you'll start to see the difference between valid and invalid in terms of the structure. Let's look at the next argument.
Okay.
Now this looks very similar. It looks like almost the same argument.
Yeah.
But something's changed.
Flip back to.
Yeah.
So look at the difference. They do look very similar. So this is an argument that many students, when they first look at it, think it looks invalid, but it actually turns out to be valid.
And there's complicated reasons for why in terms of logic, which we'll talk about later. But let's talk through the surface reasoning here.
All right. Well, I mean, most people, they look at it, they say that looks fine. I mean, they say that something's fishy with this argument, it doesn't look right, they think it's invalid. But when you think about it, the first premise says, if Malia goes swimming, then Jose goes swimming. So every time she swims, he swims, no exceptions. That's what it says. He's not going to swim today. The second premise adds, Jose's not going to swim today. Well then, if that's all the information we know, that's all we need to know that Malia will not swim today. Because if she did swim today, well, let me back up.
Sure.
If she swims, he swims automatically. Knowing that he's not going to swim today, she's not going to swim today, because if she did swim today, he would swim today, and he's not swimming, so she's not swimming. That's how I like to think of it.
Yeah.
Yeah. Knowing the premises alone, we can be assured the conclusion is true. Because if she did swim, he would. He's not, then she's not. So it's valid, although
Yes.
it's misleading to
It does.
people.
It can be very confusing when you look at this and you can say, well, that seems like it's going the wrong way. It's doing the wrong thing. But when you look at it, it's actually a valid argument.
Yeah.
It's not sound, as Paul tried to explain earlier, or we don't know if it's
We don't
sound
know
yet.
if it's sound
It
or
might
not,
be,
but it's clearly
we can
valid.
clearly say that it's valid.
In virtue of an abstract structure.
Right.
And in logic, you'll learn that we represent that structure if P, then Q, not Q, so not P. So in logic, we take an argument that has a content and we translate it into an abstract structure using symbols, and then we study the symbols. And there's ways of actually showing in almost a mathematical way that any argument that follows this pattern will be valid.
That's right. So what that means is you can plug any value into P and Q and it would still be valid. You can even put nonsense. You could say if foo then bar, not foo, therefore not bar. sorry, not bar, therefore not foo.
Yeah.
That would still be valid, even though the terms are nonsense. They don't refer to anything. They don't mean anything. It's still a valid form. And if that bothers you, work your way through the lessons, and you'll hopefully see the value of doing that, right? It doesn't matter what terms you put in for validity, but when you get to soundness, then obviously you have to be working with real content.
Yes, and what shows us the problem is when we look at it at the level of form rather than content.
Yes.
Then we see the problem.
That's right. Here's another one.
And this one I chose as an example of an argument that many people don't think is valid, and yet it is, again, that it's often students think is not valid, and yet it is clearly valid. So
It's a valid argument.
So we have to think it through. A common response to this argument is, okay, if it's raining, the roof is wet. It's raining, and they will say, but the roof might not be wet, and so it's not valid. In other words, they say the premises don't prove the conclusion with certainty. And then I often will say, why? What's the problem here? And they'll say, well, if it's raining, the roof is wet. I'll grant that. And it's raining. Yes, I'll grant that. But then they say, here's the house. They say, what if there's a big tarp over the roof to prevent the roof from getting wet? They say, what if that's the case, then the roof won't be wet. And so then they conclude from this idea that that's an invalid argument. And so this is, again, and it's an example that I'm using to show where logic can improve our reasoning. If you think about it, if someone had a tarp over the roof that kept the roof dry, then what would that mean?
This premise is not true.
It would mean that the first premise is not true. Now, to call this valid is simply to say that if the premises are true, if they're true, then the conclusion must be true. So it's all based on if-then. If the premises are true, there is no tarp over the roof.
That's correct, because the first premise is telling us if it's raining, it must be the case that the roof is wet. It's not possible for it not to be wet. Right? That's what that first premise is telling us. So that's why when we assert that it's actually raining, we know the roof has to be wet with certainty, because that's what our first premise tells us. Now, if there's a tarp, then we would never make that first claim. We would never claim if it's raining, the roof is wet, because there might be a tarp, right? So based on but we're looking mainly at the structure, right? This structure is the
this structure makes it valid, not the content, the rain, the roof.
That's right.
But
for the same reason that we saw in the last argument. All right, now I want to spend just a couple. I think we have 2 more slides left, and I want to spend a little bit of time on inductive arguments. And the reason for this is a lot of students I found in the last 2 quarters that I've taught this online course, a lot of students seem to struggle with this format of argument. So it's a really good format because it does help you actually practice the process of induction and thinking about strength and all the rest of it. But I've noticed that students really struggle with thinking through this. So first of all, quickly explain the difference between inductive and deductive arguments. What are we talking about here?
Okay, so again, logicians distinguish between deductive arguments, which attempt to show their conclusion must be true with certainty, and inductive arguments, which aim a little lower. They only try to show that the conclusion is probable but not certain. Probability is a concept from everyday life. When Paul and I leave this studio, I'll head to my car, and my car is probably going to be where I parked it. But of course, I'm not certain it will be there. It's all probability. I think it's a very high probability.
Yes, sure.
So most things in life revolve around probability estimates. But an inductive argument attempts to show that its conclusion is probable.
And that probability is a range, right? It could be a low
It's
probability
a range,
or a high probability.
Yeah, I mean, for the sake of our discussion, we can say 0.5 and above, but less than 1.
Yes.
So more than 50% probable, but less than 100% certain. We'll call that probability. So now we have an argument It's an inductive argument because of the presence of the word probably. We interviewed 10 randomly selected adults from the kingdom of Ruritania, an imaginary land, and we found that all 10 play soccer. We conclude that probably all adult Ruritanians play soccer. Probably. And so that argument has, we would call that, well, it depends on how big the kingdom is. Let's say the kingdom of Ruritania only has 200 people.
Yes.
It's a very small kingdom.
Yes.
I would call that a pretty strong argument because the premises,
The sample size is...
if true, I think that makes it somewhat probable that above 50% that all adults Ruritanians play soccer. That's a fairly strong argument.
Okay. So hopefully, again, pause the video, look at the argument if you're not seeing it, and see if you can see why that probability is...
They're randomly selected.
Yes, randomly selected.
They all play soccer.
Right. It's not specifically calling out men or women. It's just a sampling of all the adults, right?
So now we can think about our response when we make some elementary changes. So let's change the conclusion to most adults Ruritanians play soccer. So previously we said they all do. Probably they all do. Now let's say probably most do.
Now, in my course, when students see this, they believe that the strength of the argument goes down because we're using the term most, which is weaker. All is a strong statement. Most is a weak statement. So the conclusion that students tend to draw is, okay, that's a weaker argument. The strength of the overall probability is weaker because we're using a weaker term. Instead of having that all-inclusive term, we have a less inclusive
Very good.
term.
And that, in fact, the logical truth is exactly the reverse
That's
of
correct.
that.
The strength goes up.
So it's a logical and optical illusion, but when we say most probably played soccer, that's actually, that conclusion has a higher probability than the one that says all probably play soccer. And the reason for that is that when we draw an inductive conclusion, we're making a claim. And the more narrowly we draw the claim, the more precise our claim, the more chances there are that the claim is false. And the more broadly we draw the claim, the more chances we have that the claim comes true. So to go back here, if even one Ruritanian adult Ruritanian doesn't play soccer, just one, then our conclusion that all adult Ruritanians play soccer is false.
That's right.
But now in this case, if one adult Ruritanian doesn't play soccer, it's still true that most of them do.
Right.
So we have more chance that this is true based on the evidence than that this is true.
So what you said there is more chance that the second conclusion is true than this one, and that more chance means that the argument is stronger. It's a stronger inductive argument, even though it might seem intuitively opposite, right? You see a weaker phrase, a weaker term, and you automatically think that the argument is weaker, but that's not how it works. The weaker term actually makes the argument stronger. And that's also true to at least, changing it to at least half. Now you're reducing...
I'm making a weaker claim and a more general claim, and this is even more highly probable that 51% play soccer. That's even more probable on the evidence than the first conclusion.
Right. So it's very important that as you're working through these arguments that you think very carefully about what the arguments are claiming and think of strength as the probability of the degree of strength as the probability that the conclusion is true.
Based on the premises.
Based on the truth of the premises, right?
Now,
what are you doing here?
Well, so now we have the reverse orientation. So now we're going to add a premise to the argument. The 10 adults, they wore beards. No other Ruritanians wore beards. So the 10 adults that we interviewed, we're going to add that they all wore beards, whereas no one else wore beards. Does that make the argument stronger or weaker?
I don't think it has any impact on the argument. The wearing of beards does not seem to have any impact.
Well, this is where people will disagree because it is somewhat subjective here. It seems to me that that weakens the argument for this reason. We've got a sample of 10 randomly selected adults, and we're making an inference about all the adults in Ruritania. So this premise tells us that those adults in our sample are a little different from the rest of the population.
So it's only half the population because they're all men? Is that what you're
Well,
agreeing with?
no, all we're assuming, oh, because women don't have beards. I didn't think of that. I didn't actually.
So walk through your reasoning.
Okay, so my reasoning is that when we add this premise, we're now adding the additional information that our sample is different.
Because of this. This is very relevant.
Yeah, none of the other Ruritarians wore beards.
Got it, I see.
So our sample is a little bit oddball from the rest of the population, which weakens our confidence that what we learned about the sample is true of the rest of the population.
Sure.
It just weakens the argument.
Yes. Now, if we didn't include this, it may not have any impact. But because we've included,
yeah, that's right.
Because we've included that.
But because they're the only ones wearing beards, it suggests that there's something unique about them, which means that our inference from them to the rest of the population is a little more suspect than it was before we knew this.
Got it.
Okay, so that shows, you want your sample to be random and you want it to be diverse, you want it to be representative.
Yeah.
If there's some reason to think the sample is special or not random, that casts doubt on your conclusion and makes it weaker.
Now, this is a great example, and our conversation is a good example of how determining the strength of inductive arguments can be tricky. And we acknowledge this in the course. The examples that we try to provide in the course, which largely come out of your textbook, are a little bit simpler. So we're not going to do tricky things like, well, only men wear beards, therefore we're only interviewing men. Or, we don't want you to make those inductive leaps. But you can see that trying to find the strength can be tricky. So our recommendation is that you slow down. You make sure that you go through that material multiple times if you're not getting it, and just practice. Walk through the exercises. We have a number of samples in the coursework that are exactly like this format. We add information, and then you get to practice to see whether the conclusion is more or less probable. But take your time and work through those examples. If you rush through this stuff, particularly as you're getting used to it and you're learning, you're going to make mistakes. So the way that you avoid those mistakes is to slow down.
And I would add, if I may.
Sure.
It's tricky and it's also a little bit subjective. We don't have a precise measure of probability in a case like this.
Correct.
We would need to know more. Under certain very special conditions that require a lot more information and many more assumptions, in inductive logic, we can actually calculate mathematically the exact probability of the conclusion.
Yes.
But we can only use mathematics and calculate probabilities with precision when there's a lot more information and there's a lot of really specific information, and we have to bring in a whole bunch of assumptions. But cases like this that are close to ordinary life, the judgment of probability is a little bit subjective, although probably 90% of all people would agree that this argument makes it somewhat probable. Most people would agree within a range of a certain number of points. But this shows that the study of logic can help you see patterns of reasoning differently, see strengths and weaknesses you didn't see before.
Totally agree. And I think this is very helpful. So we're giving you this material at the beginning of your study so that as you go into the topics on inductive and deductive reasoning, you'll start to know what to look for. And so there's some terms here that you may not be familiar with, but you will become familiar with them and you'll learn how to use them and apply them as you work through the material. So Dr. Herrick, thank you so much for spending some time with us.
Thank you,
really
Paul.
good to have a conversation and take advantage of your expertise. Your book has been a fantastic addition to the course, and it's really great to have this conversation.
Well, I appreciate your using it, and thank you for your compliments too.
Yeah, thank you, and thanks for watching.
Thank you.
We hope you enjoy the next two modules.